Cool. All right. So maybe a good place to start was, yeah, I don't know how you went about solving the challenge and how entertaining you thought it was. I hope that it was fun. I thought when I did the
Yeah,
other one, it was pretty fun. So, yeah, what kind of I don't know what kind of process you went through, and if you made any tooling along the way, or like what did that look like?
yeah, sure. So it actually took me a while to get around to this challenge. Like I picked it up on my radar, and then I actually saved it for a flight. I was going on a long haul flight, so I was like, you know what, this would be a perfect challenge for it because no input required, right? It's just an image. So I saved it for that. So my thought process going through it, I started off, it's a blurred image, right? And then there's a piece of text on top of it. So step one, find what font you guys use. Good assumption that you probably blurred the same font that was in the image above it. So I found a font on Linux that was close enough. It wasn't perfect. The spacing of the letters were a little bit off, but for the most part, the characters looked about the same. Then the next step was to perform a deconvolution. So it's like a standard image processing technique for taking a blurry image and trying to get a little bit more detail out of it. So I actually have everything running in a Jupyter Lab. If you want me to screen share to point at things, it might be a little bit more entertaining.
Yeah, that'd be cool. I'd love to see some code.
Oh, both the cats are temporarily in my camera.
My cat Faraday just went running. I don't
Faraday
in the house.
How do I present with this tool?
There should be like a little drop down that says like open share tray. If you're on Chrome, I know that should work. If you're just doing this in browser.
I am on Chrome. Open share tray. Okay.
Yeah.
Share window desktop. Fantastic. Can I not? Okay. Let me rearrange things.
Yep, I can see that.
Fantastic. Yeah. So, step one, import the image, just plot it out. You can see the non-blurred text and the blurry text.
Yeah.
Quick plot. See the W here is a little bit shifted and the N here, but overall, like the characters match up well. Next step, I'm assuming a Gaussian kernel.
Is that a diff between your created text and the actual one? Oh, yeah, you got it. Yeah, so it's precisely then. Yeah.
The blue and the red shows the difference between one way or the other. But overall, yeah, I got lucky. I'm not sure whether this is the exact font that you guys used, but close enough is good enough in this case.
Yeah, it was actually just whatever is default in Ubuntu on typing it out in GIMP.
Oh, there you go. OSINT.
So I think, deja vu sans, I think, might be correct.
I wonder what's going on with the spacing then. I might have a slightly updated version. I don't know. It's so close.
Yeah, I know. So I ran into the same thing with Unredacter where, so it's not just font. Font is one thing, but there's also word spacing and character spacing are separate parameters that are distinct. So like you have to set those individually as well.
Yeah, there was a spacing parameter here I didn't play with. I think it's...
Yeah, but those are actually two. There's word spacing and character spacing. You can set, like if you do it in HTML, so like that's what the Redactor does. You can set those individually, and that it's very sensitive to that actually, because if you're off by like a pixel, it cascades until by the end.
Yeah. So yeah, I thought, okay, I found the character set, or at least, right? Like I don't know the spacing, but I know the character set.
Yeah.
After that, dealing with the blurry part, I'm assuming a Gaussian kernel. I was half hoping you guys did some funny kind of blurring kernel, like a either non-circular or something funny, but I assumed Gaussian for the most part. Then
you're correct. You just said Gaussian blur. Yeah.
Yeah. Nice. And the next step was to do a deconvolution. So doing this in the Fourier space was easier. Fantastic example from OpenCV for this that I kind of was inspired by. So played around with it a little. So I blurred the reference text and de-blurred it. And for the most part, like it's almost visible to a human. So I'm like, all right, let's just apply this straight to the challenge. If you squint at this just right, I think you can almost type out the solution. There's some ambiguities around here at the end, but you can get the gist of things. You can kind of like, okay, it's roughly this many characters long. And then just, some basic functions to help me write a cost function for optimizing. This is actually outdated code, but then I just let the computer loose, and it just searched through a character set. I can see from that it's alphanumeric with some symbols and space. And then I do the search such that it searches one letter ahead and then loops back and research it, because the next character influences the current character. So there's a little bit of cycling going on, makes it run a little bit slower. And then after each letter it finds, it do a global optimization for like the height and darkness of the text used. And it just runs through the optimization, pulling out the text. And after all of that, I don't know quite what happened here. I have the cost function based on how wide the character is, and a shorter character artificially makes a good score, whereas just by the fact that it has less things to compare against. But at the end, this is close enough. This is the text. This is the blurred text.
Nice.
My reconstruction of it. The diff, which I don't think was color scaled correctly. But if you look at the thing that the cost function actually operates on, which is the de-blurred version, they get very close. And then end of day, I did a sanity check where I pulled out a couple of question spots, and the human's the best for these kind of things. And I could spend an extra few days tuning my cost function, but plotting all the variables with the before and after letter, and it's just comparing which letter was more optimal, and that was that.
Wow, yeah, that's really cool.
Yeah.
So, are you by chance a ML workflows?
So I did do some ML in my uni days, but it's not mine. So it's, for me, this is more DSP, like digital signal processing. I did a lot of image processing in a few years ago. So when I saw this, I was like, this is very image processing, just straight up maths. It would have been fun to write like a neural net to do the string reversing. So like from the deconvolved part to the string, that part could have probably been fairly nicely neural net. But it wasn't.
Yeah.
The simple optimization was close enough to get within the ballpark.
Yeah, I think I agree. Here I'm just for your own reference, I'm uploading the original image that I created off of this, so it has the like. So if you ever wanted to look at it again, I mean, you were exactly correct on the solution, but yeah,
that's cool.
Go ahead.
Oh no, it's just I really like challenges where everything is so exposed and simple. Like it's literally a PNG. All the information you need is in that PNG, and it's just like it's a nice problem.
Yeah. It seems so strikingly obvious that it should be possible too, right?
Yes.
Like like you said right off the bat, if you squint, you almost feel like you could read it. But not
it's
quite.
Far off enough that you can't just read it. Like if you just try to read it, like I did a first pass of just reading it, and I compared that answer to my final one. I'm like, yeah, I would not have gotten it correct.
Yeah, we so the challenge itself is a reference to Sneakers, the movie, and we were a bit concerned that maybe it was too obvious, and that like if you get part of it and you just Google for it, you get the rest.
Oh, really? You could have?
Yeah. Huh. I think the beginning of it, like if you take some of those digits You just Google for it, then you get the rest of it. Because it's like some of the bits on screen in the movie Sneakers.
I honestly did not get the reference.
Oh, really? That's funny.
I had no other way of checking this apart from emailing it in.
That's actually more impressive, perhaps.
There was a few question marks. Like I was like very confused by the structure of the thing. I'm like, I was expecting a little bit, like I was so confused by the resulting text. So.
But it was so definitely correct. Like you could see the letters and numbers.
Yeah. I was curious when you constructed the challenge, how you chose like how blurred you made it, like how much blurring to apply.
I kind of eyeballed it because I wanted it to be kind of at that space where, like we were saying, you can't just read it. So I blurred it a little bit, and I just like went to the other side of my room and like squinted from a distance, and like, yeah, you can't read that. But I definitely wanted it to still be possible. Like if you just blurred it into oblivion, you would never.
Yeah. Well, when I was doing the deconvolution, right, I found that like 30 or 40, you can still very clearly reconstruct the original text. But like the distribution of 50 that I think you guys ended up using from my, optimizations, that got to a point where I can't just simply take the de-blurred image and just type out the text. So I was wondering whether you guys actually use that as a metric to
not explicitly. It was kind of just eyeballing it, frankly. Maybe I got lucky.
I feel like any more blurry would have probably made this approach like
much harder.
Much harder. Yeah.
Yeah, it's funny that the tooling you created was like very similar to the process that I did with Unredacter, where like the fundamental idea is like, one, make sure you can reproduce the sample text reliably, and then kind of like brute force, or in a smart way, brute force out the characters while producing your own blurring effect, right?
Yeah.
And then really ingrained in that is the idea that you can like faithfully reproduce the redacting technique, though, and that's like kind of hard because, like you said, there's definitely more than one blurring effect. So I didn't want to make that super hard because, like you said, there's definitely like different ways of like smudging and like different kind of blurs, and I think the Gaussian blur was like the first thing that everyone would think of. So I just went with that.
Yeah. How many people ended up solving this challenge? It was like, I think it was 2 when I mailed it in, but I wasn't sure whether after DEF CON with the...
Yeah, that is a good... I know that we got, I want to say it was 3.
Nice.
Like basically correct submissions. I think there was one that was like off, like had like one character that was like wrong. And I was like, I'll take it. So we went ahead and gave him a thumbs up because it was like all but one character. Again, it was baffling to me. Like, if you just Google it, I swear you get it. Like, I'm not just.
Now I'm really tempted to Google it.
Yeah. I have to send you a link. That's like the. Oh, but yeah. Cool. Yeah. So like you said, also being able to do this offline is kind of nice. And that one of the troubles with like CTF challenges when we put them up is like, we have to like stand up some infrastructure.
Yeah.
And what if it goes down? And what if you can solve it using something we didn't think of? Or like, that's kind of
right. But this is a very self-contained.
Yeah. What was your anecdotal impression on like how easy or hard this would be in less controlled circumstances, or like if you had like a video file where someone's blurring something, right? Like how implausible, how hard would that be to like more generalize the system?
So it was funny because when I saw this challenge, I was thinking about writing some challenges of my own where a video file was one of the thoughts. Like the concept being, you're videoing the screen of someone who accidentally showed their password, like passcode or something, but just at that moment your autofocus kicks in, and either it does the sweep of focus, which will give you a lot more information, or it landed on just a bad focus. And once again, we get back to the point of how faithfully you can create the image prior to the perturbation that you're after, right? So then in that challenge, you'll probably put markers on the screen so that people can easily undo the geometric transform. And you'll probably, like, for the video part, correct for the lens distortion so that like the challenge isn't too hard. But the video idea is good because you get multiple frames instead of the image single frame.
That is true. Yeah, I hadn't thought of that angle. Maybe that actually provides you with a lot more information than you're like kind of thinking.
So at the start, before I found this current approach, like when I was still tinkering around with this challenge, I was looking at the RGB channels, and there are some variations in the way that the channels are aliased that causes fringe patterns. And I was wondering whether you can use those fringe patterns to get edges on the original text, just because those are the pixels that tend to vary, like, you know, when aliasing is applied to have random values. That didn't pan out very well, but that would have been an interesting approach to this.
Yeah, fascinating. Do you know if there's any other blurring algorithms that are common or used around that like are more or less lossy than Gaussian? Like one of the things I was curious about was like if there's because a lot of those transforms are sometimes not lossy at all, even though they might appear to be, right? And you can actually just undo them with some math, like fully or almost fully.
I could see certain kernels being applied that would be difficult to undo. For instance, if you had a flat top Gaussian, right? Like instead of a peak, the top is flat.
Yeah.
Then the contribution of anything in that flat section would not actually provide any information, which might theoretically might give you a visually similar but difficult to like if you were to blur something to make it look like it's been blurred, but make it difficult to unredact the information.
Right.
Having those kind of kernels might be interesting. But I don't know. It's all about like missing information, right? It's like what information you don't have deal.
Yeah, I feel like the benefit to this, like having the known metadata of like knowing that it's text and being able to guess the text, like really makes that a simpler subset of like undoing the process from a mathematical like image kernel perspective, right? Because then like if you tried to undo like a face blurring, like that's much harder.
Right. So the initial usage of the deblurring stuff that I found on OpenCV was specifically targeted at deblurring pictures. So like they do natural scene deblurring, but it does turn out artifacts of ringing. But
yeah, see, I was concerned that such an approach would like especially if you're going at it from like a neural network perspective, that like the network would try to fill in details for you, right? Which when it's a face is probably fine. Like you're going to guess that they have a nose, and the nose probably like that's fine if you're making educated guesses.
Yeah.
But when you're trying to reverse engineer out text, like of like a password, you really do have to get the actual text you can't just fill it in with arbitrary text.
I tried that when I got the cost function working, right? I have the blurring and deblurring. I tried to do like sprinkle noise into the picture and then pick out the noise points that made the final image look better and see if I can like converge into a naturally generated original image that would give me. I didn't go down far enough down that route, but the initial results wasn't very promising. Like I had some like, random dots that hung to clusters to grow into the shapes. And I would have liked that solution to work because then it will be a generalized solution, right? Because then you'll reconstruct the black and white image and then you should be able to read that clear text. But I did find the string, Googling it.
Okay. I saw that.
I put the link in chat. Yeah. So
that's fine. Yeah. Well, that would only help you if you had already gotten like half of it though. So like, whatever.
It's good when the challenge flag like helps you self-verify. Like I do like ones that are like, yep, you've got the flag. Whereas I looked at this and I'm like, I don't get it.
Yeah. It's clearly got words and numbers and dashes like it. Yeah.
Like the S and the 5 is very hard to disambiguate.
Yeah, that's fair.
So I was,
to be perfectly fair, my own handwriting can't distinguish between S. So,
but yeah, that's why I ended up plotting all of the matrix of all the different characters. Like you can as a human, very like be able to tell subtle differences between the 5 and the S that just letting an optimization just might not cover.
Yeah, that's sweet. Yeah, if you wanted, we could link to your like Jupyter notebook to like list like to show people like look check out this solution or whatever.
I might give the images, but maybe not. It's awful code. It is not a share worthy code.
Okay.
But I'm happy to send a couple of images over.
Yeah, that'd be fine. Whatever you're comfortable with.
Yeah. But no, maybe not the original source code.